we are going to take a quick break from looking at linear systems to looking at some basic differentiation formulas, and these are going to be numerical derivatives, meaning we're just going to be approximating our derivative. Okay. And so the first one we're going to look at is the centered difference approximation of the first derivative. Okay, and let's say that we want to find the derivative at x sub I here in this picture. Okay. Well, we have a few options on what we could do to find this derivative. Okay. One is we could just go a little bit to the right. Let me remove this. There we go. We could go a little bit to the right, okay, and we could just compute the slope. Or we could go a little bit to the left, compute the slope. Okay. And so those two situations are describing what are called forward and backward difference approximations. If we want a centered one, maybe we'll go a little bit to the right. So to x sub I plus 1, and we'll go a little bit to the left. X sub I minus 1. Okay. And is what we'll do is we'll just compute the slope of the secant line from here to here. And this will be our approximation for the derivative. Let me see here if I can line those up. I'm going to try that one more time. There we go. Okay. We'll find the slope of that line. And in order to do that, that would just look like m, or how about our derivative at x sub I is equal to the change in y. So we have f of x sub I plus 1. That would be the y value here. And the y value here would be f of x sub I minus 1. And then this would all be over x sub I plus 1 minus x sub I minus 1. Okay. And now if we were to add in one more thing here, if we were to call this small change from left to right, or from this center piece to the endpoints, if we were to call this small change h, okay, then the change from x sub I minus 1 to x sub I plus 1 is going to be 2h. Okay. So we could rewrite this as f of x sub I plus 1 minus f of x sub I minus 1 over 2 times h. All right, so there's our approximation for the first derivative. Okay, and we could have thought about this using Taylor series and gotten to the same spot. And in fact, that's what we're going to do for thinking about our second derivative. Okay. And so you can see down here, I have actually our Taylor series for some function f centered at a. Okay. And we are going to think about two different Taylor series, and then we're going to combine them, and then we'll get a nice little formula for our second derivative. All right, so in place of x here, I'm going to be plugging in x sub I plus 1. I just want to note that's what's going to be x there. And is what's going to be a is going to be x sub I. Okay. So we're evaluating this function at x sub I plus 1, but our Taylor series that we're going to be using to do so is going to be centered at x sub I. Okay. All right, so next here we have plus f prime of a, so that's f prime of x sub I all over 1 factorial. And then we'll have an x sub I plus 1 minus x sub I. And we're going to do one more of these, plus f double prime of x sub I all over 2 factorial. And then this is going to be times x sub I plus 1 minus x sub I squared. Okay. So we see what x in A is. We're going to also call this right here h. And so then this would be h squared here. And I do want you to note that this Taylor series would keep going here. But the way that we could go in and write this is f of x sub I plus 1 is equal to f of x sub I plus f prime of x sub I. And then if we were to subtract these two, that's going to give us h. So we'll place an h here. And then finally on to that second derivative, f double prime of x sub I over 2, right? 2 factorial is just 2, and then times h squared. All right, and then we're going to try one more of these. Okay. But this is one of the formulas that we're going to use. Okay. Let's see what the next one's going to be. The next one, we're going to plug in x sub I minus 1. But we're still going to center it at x sub I. And then we'll have plus, and we'll have f prime of x sub I all over 1 factorial. Okay. And we don't really need to write that, do we? Okay. So we won't. Let's just write f prime of x sub I. Keep this simple. F prime of x sub I. And then we want to multiply by the difference of x sub I minus 1 minus x sub I. Okay. Right, this is the center, this is the x value. Now remember, x sub I is going to be h units bigger than x sub I minus 1. Okay. So this is going to give us a negative h if we subtract these. Okay. So what we'll do is we'll go in here and we will write in a minus and then times h. And then on to the next one, we're going to have plus f double prime of x sub I over 2 factorial, or how about just 2. And in this part here, where again we'll have x sub I minus 1 minus x sub I, we'll end up getting a negative h, but then when we square it, okay, that's going to give us positive h squared. And so here's the two formulas that we need. And we're going to go ahead and we're going to add these two together here. I'm going to get rid of this. All right, and so if we add these two together, we have f of x sub I plus 1 plus f of x sub I minus 1 is equal to, and you can see that we have these two f of x sub I stacked here, so it's going to be 2 f of x sub I And then next on our list, you can see that the first derivatives times h will cancel. And then if you were to add the two last terms together that we're including, okay, we're going to end up with plus f double prime of x sub I times h squared. Okay. And the fact that we're not using all the terms of the Taylor series is what's making this an approximation. Okay. All right, and so is what we're going to do next with this green formula we have here, which, let's point out where it came from again. This came from adding those two equations. Okay. And so let's again finish solving here. So if we were to move things around here a little bit, let's maybe just subtract by this on each side and then divide by h squared. So that's going to look like f double prime of x sub I is equal to, and I'm going to just write this in the same order that it's going to appear in your textbook, but we have these two added together minus this one. I'm just going to put this right here in the middle of them though. So minus 2f of x sub I plus f of x sub I minus 1. Okay, and you could see why you might want to write it in this order, because you go x sub I plus 1, x sub I minus 1. Okay. And then this is all over h squared. Okay. And so we will be using this formula here and the one up above for the first derivative. Okay. Let me remind you of the one for the first derivative. We got it right there. Okay. All right. So let's go ahead and we're going to switch over to another tab here and look at an example. All right, so we have switched over to another tab here. We have spring mass system. And so this is actually a differential equation that you all probably would have looked at in differential equations. Right? And it is meant to describe the displacement of some mass as time varies. Okay, and this mass should be attached to a spring. So m here actually represents the mass. K is the spring constant. And gamma is the damping constant. Okay? This has to do with kind of slowing down the spring mass system. Okay. All right, and we're given a couple conditions. We're given that the initial displacement is 1/2, and then we're given at the end point, okay, 2 of our interval, the displacement is pretty close to 0. Okay. All right. So the next thing we're going to do is we're going to actually use these derivatives we have here and plug them into the differential equation above. Let's start that process here. All right, so we're going to have m, which is 1/2. Okay, so there's m. And then we're going to have times u double prime. And just for the sake of brevity here, I'm going to write u sub t plus I, okay, rather than u of t plus I, and that should be plus 1. Let me fix that. Oh, that's why I'm messing up here. Let's try that again, one more time. U of I plus 1 rather than u of t sub I plus 1. Okay. And minus 2 u sub I plus u sub I minus 1. Okay. And then this is all over h squared, which we need to, let's pick an h here for ourselves. So how about we choose h to be a quarter? Okay. So as we go from one u value to the next, we're just, the t value is just changing by a quarter. Okay. And so that means that down here, right, we should have h squared. Okay. So that's going to be 1/4 squared. Okay. And then just write 0.25. Okay. So there's that part taken care of. And then plus gamma. So plus 5/2. And then this time times u prime. Okay, so this is going to be multiplied by u sub not t, u sub I plus 1 minus u sub I minus 1 all over 2h. So 2 times 0.25. So that's just 0.5. Okay. And then we still have plus k. So plus k, so that's 18. And for this last part here, we'll just say u sub I. Okay. So again, u sub I. Okay, and then this is all equal to 0. Okay. And so you might be looking at this wondering how on earth this is going to help us. It ends up, we'll be able to turn this into a system of equations that we will be able to solve. Okay. So let's keep going here. We're going to try and simplify this a little bit. Okay. So for one, this 0.25 squared or 1/4 squared should give us 16. So if I have 16 over 2, that's 8. So I'm going to have 8 times all that stuff in the numerator. I'm going to have 8 times u sub I plus 1 minus 16 u sub I plus 8 u sub I minus 1. And then we have divided by a half. So this is going to be 2 times 5/2, which is just 5. Okay, so that's 5 times u sub I plus 1 minus 5 times u sub I minus 1, and then plus 18 u sub I equals 0. And I think we can do a little bit of simplification here. Let's look at u sub I plus 1s first. I see only 2, so it's going to be 13 u sub I plus 1. Okay, good. And then u sub I next. So it looks like we have 1 here and 1 here. So 18 minus 16, that's plus 2 u sub I. And then lastly, we have 8 u sub I minus 1 minus 5 u sub I minus 1. So that's plus 3 u sub I minus 1 equal to 0. Okay. All right, and so it is this that we are going to be able to transform into a system of equations, this thing right here. Okay. And we're going to see how here in 1 second. So the last thing that I want to do before we start trying to turn this into a system is I would like us to just reorder things. Because right, when we usually make a matrix, you'd have, you know, x1, x2, x3 going in order, right? And right now we're going in descending order rather than ascending. Okay. So if we just rewrite this as 3 u sub I minus 1 plus 2 u sub I plus 13 u sub I plus 1 equal to 0, this will now be easier to write as a system. All right, so the first and last equation are going to be a little bit more complicated than all the ones in between here. But let's go ahead and first make one more note that if we are to, say, start with I being, actually I want to reword that a little bit more even. If we were to start off with u sub 0, okay, well, we determined that that initial displacement was 1/2, so I'm going to write that in here, 1/2. And then our final at 2 is 0.006. Okay? And let's try to think about, well, how many u's are we going to actually wind up with here? So if this is u naught, which is at a actually a t value of 0. Okay. Let me actually write that up here. That's the t value, not the displacement. And we're to count by quarters, so here's 1. And so this would be U1, U2, U3, U4. And I'm going to keep going. So here's finally 2. And 5, 6, 7, 8. This would be U sub 8 is where we're going to end this. Okay. So I want to point out that U sub 8 is going to equal that 0.00. Is it 3 zeros? Yeah, 3 zeros. I'm going to just move that a little bit away from our number line. But this is how we're going to start and end. Okay. So if we were to write our first equation, here, this should be 3 u naught plus 2 u1 plus 13 u2. And let me do this. Okay. This is all equal to 0. Okay. But remember, we know u naught is 1/2. So we could rewrite this one over here as 2 u1 plus 13 u2 is equal to minus 3/2. Right? That's just subtracting this over and using the fact that u naught was 1/2. Okay? And then the next equation, okay, so I'm just going to let the i's increase here in this thing down here. So the next one, we could start it at 3 u1 plus 2 u2 plus 13 u3 is equal to 0. And then we'd have another one, 3 u2 plus 2 u3 plus our next one, which would be 13 u4. And we'd eventually get down to our last couple here. Remember, we're going to end with a u sub 8. Okay. So we'll eventually get to 3 u sub, let's see, yeah, let's try 5. 3 u sub 5 plus 2 u sub 6 plus 13 u sub 7 equals 0. And then finally, we'll have 3, and I'm going to write it over here, 3 u sub 6 plus 2 u sub 7 plus 13 u sub 8. And this is all equal to 0. But remember up here, we know u sub 8 is 0.0006. So that's 13 times 0.006. There we go. And so if we were to subtract this over, then is what this is going to look like is a 3u sub 6 plus a 2u sub 7 is equal to minus 0.0078. Now let's start thinking about what this system looks like if we write it in terms of a matrix. Maybe I'll zoom out here a little bit. I'm going to try and write it right below this. All right, so we can see that in our very first equation we have a 2u1, and then in the next equation we have a 3u1. And then let's also note how many equations we actually have here. Okay. So we have, let's see, 1, 2, 3, and let's think about what we'd be missing in the middle. We'd be missing a U3, a U4. I'm talking about what these begin with. Okay. And then we have our U5 and our U6. So we have 1, 2, 3, 4, 5, 6, 7 equations. So the rest of these don't have any U1s. So I need to put down here 5 more zeros. And then next, okay, we'll start on the U2s. So the first one's a 13. Okay. After that, it's a 2. Okay. And then after that, it looks like our next U2 is a 3. Okay. And then if we move on to U3s, we actually don't have one in our first equation. If we look at our next one, we have a 13. And then our next U3 is a 2. And then after that, let's see, we're on this one right here. So then the next one would be a 13. Oh, let me fix that. I said the next one would be a 13, but it should be, if I were to look down at the next line that I haven't written here, I would have had a 3, U3 to start it off with. So the next one should be a 3. And then all zeros below that. And you might be starting to notice a little bit of a pattern here. So what's going to happen is in this one here, we're going to have a diagonal of 13s, diagonal of 2s, and a diagonal of 3s. I'm just trying to keep these in line, because if I'm not neat here, it's going to be hard to tell. And let's see, right now we're at 1, 2, 3, 4, 5, 6. So we have one more to go here. So this next one here, just continue the process. There we go. So this is just the U portion of this, and then on this side, the augmented, if we augment this, remember the first equation has a minus 3/2 up here. The rest of these are 0 other than the last one, and the last one is that minus 0.0078. And so let's go ahead and plug this in on MATLAB. And actually, you know what? We've already been going for 30 minutes here. We will put this into MATLAB tomorrow and solve this system. And we'll compare our results that we get with the actual solution. So there's a lot of differential equations we can't solve by hand, but this is actually one that we could do. So we can see how well our approximation matches the actual answer. Okay? And then we'll come up with another way of solving systems that look like this. These are called tri-diagonal systems.